Okay, well, welcome Thursday. End of the week for us though, right? And we are going to go over section 3.5. And I have this worksheet. Oh, let me bring it down here. And it has a whole bunch of graphs on it, although I don't know how to rotate this view. Let me rotate. Oh, rotate. There we go. Okay, so we have this worksheet, and we're going to be going over it. If you notice on the top of this worksheet, it says all the sections. I think there's 5 different sections that will actually refer to it. So 3.5, which is today, 5.3 in Chapter 5, Chapter 7, Chapter 9, and Chapter 11. So we will refer back to this. This was not created by me, but it was created by another math teacher, and she said, hey, yeah, go for it and use it. I'll show you which shapes that you should know, but just in general, if you notice in number 1, that's a quadratic equation, but the shape is a parabola. So it's got this U shape, and y equals x squared is in general what it is. And then if you have a negative out in front, that means you're going to flip it. Then there's what's called translation. So if you move it left, right, up, or down, that's this down here. So she gave an example of each type of graph. And how you do that. And if you go to the next page, we've got reciprocal function, we have, and so forth. So we're going to talk about some of these today. The one at the end is a linear, although she only wrote y equals x. If you want to put y equals mx plus b, y equals mx plus b, you'll see an example of one down the bottom for 8. Okay, so again, we'll refer to that off and on today. And let's see, do you have any questions from the homework? Any pressing questions from the homework? Okie doke. So let's go ahead and get started then. We are going to be talking about relations first, and then functions. Before we get into functions, we're just going to have some definition. What's an independent variable? What's a dependent variable? And let me just write some stuff on here. So this is the title way up on top of this section, 3.5. And then independent goes with the x value if your x is along the x-axis. And your dependent are the y variables. Now, we're going to look at some word problems or some other axes where you don't have x and y. Maybe it's t and c. Okay? So if it's t and c, then the t would be independent and the c would be dependent. Okay, what's relation? What's a function? Domain and range. The domain are really the x values, and range are the y values. And I will write that again when we go over it. Okay, and then we'll look at graphs. That's when you'll need that worksheet. So you can look at a graph and tell stuff about the function, if it is a function and so forth. Okay, so let's look at independent and dependent variables. This is kind of just showing independent and dependent. Now, you don't have to copy all this down. But again, if you are on an XY coordinate plane, that's how they describe independent and dependent. Independent, some books will call it the control variable. It controls the situation. So if you think about it, let's look at this first one up here. The amount of your paychecks depends on the number of hours you worked, right? So if I were to say X and Y, the number of hours controls how much money you get at the end of the week. So your X would be the independent or control variable. Okay, so down here, what's going to be the control? The cost or the number of gallons? Cost or the number of gallons? What's the control? Okay, number of gallons, and so your Y would be your cost. And so forth like that, okay? So just so you know, that's just kind of some descriptions. Now let's go into what's relation, what's a function. Okay. Relation is just a set of ordered pairs. That's it. So maybe you got 1, 2, 3, 2, 3, 0, and so forth. Just a set of ordered pairs. That's one way to think of it. Now a function, write the definition of a function. A function is that there is, I don't like the way this is worded, so I'm going to write it my own way. Okay? So my own way is basically, write this down. A relation, and you can write down the book if that makes sense to you, is a function if every x is matched to, now I'll use the same words, exactly 1 y. Every x is matched to exactly 1 y. That to me makes a little bit more sense than up above in the blue box. So here is,
could you give an example?
Yeah, that's what I was just going to say. Here is an example. One way with ordered pairs, they'll look